Welcome to Sir Dave's Math. In today's video, we shall be looking at graph of inequalities in two variables. So before we start, we shall be looking at some rules or guidelines that pertain to drawing the graph of inequalities in two variables. So when you have a solid line as a boundary line, it applies to greater than or equal to or less than or equal to. But when the line is broken, like what you have here, this is for less than or greater than. So do not forget, when the line is solid, thick, continuous line, it is for greater than or equal to or less than or equal to. When it is broken, it is for less than or greater than. Now, for these examples here now, it is on your y-axis. This is on your y-axis. It can also be on your x-axis. So if it is greater than or less than or less than or equal to, it will be on your x-axis. So you can decide to shade this way, depending on the range, or you can decide to shade this way, depending on the range. Same thing here. If it's on your x-axis, it can be broken lines this way, broken lines this way. That's for less than or equal to. Sorry, that's for less than and for greater than. So when it is broken, it is for less than or greater than. When it is thick continuous line, it is for greater than or equal to or less than or equal to. So let's take an example. Show on a graph, the question says show on a graph the area or region which satisfies the following inequalities. Show on a graph the area or region which satisfies the following inequalities. So we'll start with this one where we have y is greater than or equal to 5. There's nothing to solve here. What we'll just do is to plot our graph. So this is your x-axis and this is your y-axis. So let's call this 1, 2, 3, 4, 5. So since this is 5 and it's on our y-axis, we'll have a continuous line because this is greater than or equal to. And then what region are we going to shade since it is greater than or equal to 5? So everything above 5 falls within that range of greater than or equal to 5. So we'll shade above this 5 mark. If it was y less than or equal to 5, then we would have shaded downwards. Everything downwards will be y less than or equal to 5. So let's check the next example. We have 2x plus 3y less than 18. (2x plus 3y less than 18). So in solving this, we would assume that x is 0, and then we'll find the value of y, and then assume that y is 0, and find the value of and then find the value of x. So when x is 0, 2 bracket 0 plus 3y less than 18, 2 times 0 is 0, so we have 3y less than 18. Y becomes 18 divided by 3. 3 will cancel 18. Y less than 6. Again, we'll assume that y is 0. So when y is 0, 2x plus 3 bracket 0 less than 18. So 2x, because 3 times 0 is 0, 2x less than 18, x becomes 18 divided by 2. X is less than 2 here 1, 2 here 9. X is less than 9. So in plotting this graph, take your x and y axis and for your y axis you have 6, and then for your x axis you have 9. Let's count 1, 2, 3, 4, 5, 6. We'll mark this point. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Mark this point. So we'll take our ruler and draw a straight line. Remember for less than or equal, for less than and for greater than, the lines are broken, and for less than or equal to and greater than or equal to, the lines are thick continuous line. So we're going to do broken lines here, broken lines here, broken lines here. Now, what portion of this graph do we shade? Y talks about y is less than 6, which is below this point. X is less than 9, which is inside here. So we're going to shade below this line. This is the region that represents y is less than 6 and x is less than 9. All of this region. So please do well to go over this video again and possibly get other examples and solve.